let's talk about density a little bit, how we calculate density. So first, in order to get the density, you have to know the mass and the volume. So your mass is always going to be in grams, and the volume is always whatever is written in either centimeters cubed, if it's a solid, or if it's a liquid, it will be in milliliters. So those are some clues of what number goes where. Now, density is equal to mass divided by volume. That equation right there, that formula is the same as this, okay? It just is written differently. It looks different, but this means mass divided by volume. And honestly, this way right here is the way that you're going to see it most often. The way I tell students to remember mass goes at the top is think about, it looks like a heart, kind of. You know, you have to use your imagination a lot. But density is equal to the mass divided by volume. Now, what does your answer mean? When you get an answer, if it is less than 1, that means that that object, when I drop it in water, it should float. If your answer is greater than 1, then that means if I drop it in water, the object should sink. That's because the density of water is equal to 1 gram per milliliters cubed. Okay, so if water's density is equal to 1, then if something is less than 1, it should float. And if something is greater than 1, it should sink. All right, so let's apply this to your problems that you'll have today. So number 1 says a substance has a mass of 10 grams and a volume of 5 centimeters cubed. So right here it tells you mass of 10 grams, plus we see the grams there, so we know that that's gonna go on the top for our mass. And then it says volume of, and we have centimeters cubed, and that's our volume clue. Okay, so 10, don't even worry about these symbols here. 10 divided by 5 gives you 2. Now, these symbols, or these, for these units, are different, so they don't cancel each other out. They don't just disappear. We have to include both. So in our density answer, we have to include both units of measurement. So would this object sink or float? It would sink because it is greater than 1. All right, let's look at number 2. It says a liquid has a volume of 4 milliliters, and there's another clue, milliliters, and a mass of 24 grams. So what's the density of the liquid? Well, let's fill in our little equation here. The mass, it said, was grams, 24 grams, divided by our volume, which is 4 milliliters. So 24 divided by 4 is 6. And then we can't just leave those out. So here is our answer. Now, we are talking about a volume, but we are talking about a liquid, but liquids can stack on each other. There are different densities of liquids, and this liquid is greater than 1, so it would sink to the bottom, and water would actually be on top of this liquid. Okay, and let's look at number 3. It says a large marble is dropped in a graduated cylinder with 35 milliliters of water in it. The water level increases to 49 milliliters. What is the volume of the marble? So on this one, it's not even asking you for density. It's asking you about how to find the volume to be able to later on get the density. So this is called the displacement method. And I wish I had a graduated cylinder with me here to show you. Maybe I can try to do a little something with that this week. So we start off in our graduated cylinder with 35 milliliters. That's our starting level for the water. We drop the marble in, and it increases to 49 milliliters. So we have to get the difference there of those. So we have 49 minus 35. So 9 minus 5 is 4. 4 minus 3 is 1. So our volume of the marble is 14 milliliters. Now, if we were able to get a triple beam balance and get the mass of the marble, then we could divide it by the volume, and then we could get the density. But at this point, we don't have those things at home. All right, so I want you to do 4, 5, and 6 on your own, and I will submit the answer key later on, probably tomorrow, and kind of let you check that. But I do want you to submit your work to me as well.